Good morning, class. We are looking at Chapter 4, Application of Derivatives, Section 4.1, Maximum and Minimum Values. In this chapter, we cover maximum and minimum values, how derivatives affect the shape of a graph, optimization problems, anti-derivatives. Starting with the differentiation formulas and the definition, f prime of x is limit of f of x plus h minus f of x over h as h approaches 0. Two formats to define E. Basic differentiation formulas from the power rule to trigonometric functions. The derivative of a constant times a function, you can take the constant out. The derivative of bunch of terms, you do them term by term. For example, the derivative of the sum is the sum of the derivatives. Product and quotient rules. Y equals FOG, composite function. Differentiation results in a chain rule, f prime of g of x, g prime of x, or dy dx is dy du du dx. Therefore, the basic power rule becomes the extended power rule. The derivative of g of x to the power of n is n, g of x to the power of n minus 1 g prime. Exponential functions, the derivative is always itself. In these two cases, because of the chain rule times k and times g prime, in this case, because of the logarithmic properties times ln b. In this case is itself times ln b by the logarithmic properties, f prime by the chain rule. The derivative of logs basically flip them over. And when you have a curve with 2 points P and Q, if you connect them from P to Q, the distance of delta x or dx or BP is the run. The distance of BQ is delta y, the rise. The rise along the curve. dy is the rise along the tangent line, where dy is f prime of x dx. Linearization refers to finding the equation of a tangent line. And you don't have to memorize it, just stick with the point slope and it'll do the job. And now, maximum and minimum values. Definition, critical point. A critical number point of a function f is a number such that f prime is either 0 or f prime does not exist, D and E. So here's an example. We want to find the critical numbers for f of x equals x cubed plus 3x squared minus 24x. So here's the process. Number one, find f prime of x. So differentiate, we get 3x squared plus 6x minus 24. Number two, set it equal to 0 and solve. So when we set it equal to 0, we have to factor. We notice we can take the 3 out. We get x squared plus 2x minus 8. Furthermore, we can factor these. We want two numbers. The product is negative 8. The sum is positive 2. We get positive 4 and negative 2. Therefore, x is negative 4 or positive 2. By the way, f prime doesn't exist. This f prime is a polynomial of degree 2 itself, so it does exist everywhere. In other words, this doesn't produce any solution. Now, we want to look at extrema, maximum or minimum points on a curve. So here's the definitions. Local, also known as relative extreme value. Extrema is the plural of the Latin extremum. A local minimum is the minimum value within some open interval. Local minimum occurs at the point C in an open interval of A to B. In the domain, if f of c is less than or equal to f of x, for all x values in the open interval. A local maximum is the maximum value within some open interval. Local maximum means it occurs at a point C in an open interval of A to B in the domain if f of C is larger than or equal to f of x for all x values in the open interval. In other words, we are talking about peaks and valleys, everybody. Local mean, local max, local mean, local max within some open interval known as local or relative. On the other hand, absolute, also known as global extreme value of or extrema, are either maximum or minimum points on a curve, meaning absolute minimum occurs at the point C if f of C is less than or equal to f of x for all, and that's the key, for all x values in the domain. Absolute maximum occurs at the point C if f of C is larger than or equal to f of x for all x values is in the domain. So if we look at these two cases again, local mean, local max, local mean, local max, local mean, local max. This local mean is also an absolute minimum. Why? No other point has a smaller y coordinate. This local, so local max, local mean, local max. This local max is also an absolute maximum because no other point has a larger y coordinate. According to Fermat's theorem, if a function f has a local maximum value or a local minimum value at an interior point C of its domain, and if f prime exists at C, then f prime must be 0 at C, f prime of C. So notice, when we look at this function, this is a smooth curve. In general, differentiability depends on the type of curve, if it's smooth or not. So you see a horizontal tangent line where the slope is 0. On the other hand, this one, f prime does not exist. So local max, local mean, local max. This local max is also an absolute max because no other point has a larger y coordinate. So if f prime exists, then f prime of that point C must be 0. Note, local extremes in the interior of the function occur where f prime is 0 or f prime is undefined. Maxima and minima of a function always occur at critical points, but critical points are not always maximum or minimum values. The other way doesn't work necessarily. And local is always the interior points. Let's look at a couple of examples to find out what's happening with extrema. So this is a function everybody is familiar with. So extreme value can be in the interior or the endpoints of a function. However, it's important to know endpoints can never be a local extremum. So local is in the interior. The endpoints, they are either absolute or nothing. So y equals x squared with a interval of all real numbers, which is an open interval. If you look at this point having coordinates 0, 0, this is the absolute minimum, which is also a local minimum. I want you to know that. And the way we would write that, by the way, we would write absolute minimum is 0 at either x equals 0 or the pair 0, 0. We don't have an absolute maximum. We don't have a local maximum, nothing. So this is a local as well as absolute minimum. And in general, mean and max, they refer to the y coordinate of the function. Let's look at the same function, but change the domain to a closed interval of 0 to 2. Obviously, this is 0, 0, and this is 2, 4. This is the absolute minimum, and this is the absolute maximum, and we don't have local extremes because endpoints can't be local. And again, if we were to write it, we've already seen this one. This would say absolute max is equal to 4 at this pair, okay? Or at x equals 2, depends upon how they wanted you to write it. So you write it according to the way they ask. Let's make a change and let's make it half open, half closed. It's open at the endpoint 0, therefore this is not included, therefore we don't have a minimum. But half closed at 2, we have 2 comma 4, therefore we have an absolute maximum. And of course, we don't have local extremes. We don't have a local max, we don't have a local mean. Let's look at the same question. We change the domain to an open interval. So both sides are open. That means this point is not included. This point is not included. We have absolutely nothing. We don't have a minimum. We don't have a maximum. We don't have local extremes. There is nothing. In essence, it gives rise to the extreme value, also known as closed interval theorem, which says if f is continuous over a closed interval of a to b, then f has a maximum and minimum value over that interval. So take a look. An absolute max, absolute mean. Maximum and minimum at interior points. Absolute max, absolute mean. Maximum and minimum at endpoints, both of them. Endpoints. Absolute max, absolute mean. Maximum at interior point, minimum at endpoint. By the way, absolute max, absolute mean, this is also local max, local mean. Absolute max, also local max. These three, the endpoints are just absolute. So to find absolute maximum and minimum values by extreme value theorem or closed interval theorem, number one, find the critical points, CPs, and evaluate the function at those points, f of CPs. Number two, find the values of the function at the endpoints, f of A as well as f of B. Finally, the largest value is the absolute max and the smallest value is the absolute minimum. So in short, the extreme value, also known as a closed interval theorem, says if f is continuous over a closed interval of a to b, then f has a maximum and minimum value over that interval. Let's look at some examples. Find the absolute max and minimum values of the function f on the given interval. F of x is 1/3 x cubed minus 9x. The interval is -6 to 0. So before we follow the methodology, first we have to really discuss the continuity. So we look at the function and see what type of function we have. And I hope you see that we have a polynomial of degree 3. So what are polynomials? Recall. All functions are continuous in their entire domain. First of all, what does that mean? It means we should be able to tell the type of function, and according to the type, where the function is really defined, that is the domain, that means the function is continuous. So for polynomial functions, which is in the form of f of x equals a sub n x to the power of n plus a sub n minus 1 x to the power of minus 1 all the way to a sub 0, where a sub n x to the power of n is called the leading term, a sub n is called the leading coefficient, can't be 0, n the exponent is a whole number that is the degree of the polynomial. By whole numbers, we mean 0, 1, 2 to infinity. The domain is all real numbers. A lot of information here reminding you of what we have learned in algebra. So this is a polynomial of degree 3. That makes it continuous from negative to positive infinity, therefore in the interval of given. So f is a polynomial of degree 3, is continuous on negative to positive infinity. That means that's the domain, and therefore is continuous in the given interval. Now we can move on with the process. Number one, we're going to find f prime of x. So differentiate this 1/3 times 3 is 1x squared minus 9. Then we want to set this equal to 0. To set this equal to 0, we have to factor it. You know this is x squared minus 3 squared, and you know a squared minus b squared is a plus b, a minus b. So you have x plus 3x minus 3. So f prime equals 0 gives us two answers, negative 3 as well as positive 3. Now, f prime does not exist, gives us no solutions. This is phi, a Greek letter that represents an empty set. Now, why is this the case? Because f prime is itself a polynomial. It's a polynomial of degree 2, and the domain is all real numbers, and it exists everywhere. That's why. Now, is negative 3 in between? Yes. Is 3 in between? No. So you can't use the one that is not in the given interval. So therefore, you want to go back to the original function, evaluate it. So we are here, evaluated at the endpoints a, which is negative 6, b, which is 0, and the critical point negative 3. Let me clean up my mess. So that's what I mean by that. Let's put the function and let's plug in negative 6. So negative 6 cubed is negative 216. 1/3 of that is minus 72 plus 54. They add up to negative 18. Let's plug in negative 3. Cube at negative 27, 1/3 of it is negative 9. Plus 27 is positive 18. And if you plug in 0, clearly you get 0. 18 is the largest value. Absolute maximum is the largest value, 18 at this pair. Absolute minimum is the smallest value, negative 18 at this pair. So you write it in this fashion. Absolute maximum equals 18 at negative 318. Absolute minimum is negative 18 at negative 6, negative 18. You write this the way they want it in order for you to get the full credit. Okay, everybody? Find the absolute max and mean values of the function for the given interval. The function f of x is x plus 3 to the power of 2/3 minus 5. The interval is negative 4 to 5, closed interval. So What type of a function is that? We are going to rewrite this. Remember, the denominator becomes the index and the numerator becomes the exponent. So f of x is cube root of x plus 3 quantity squared minus 5. So what type of a function is this? This is a cube root function, essentially. Uh, just reminding you, y equals cube root of x class. The graph looks like that with the domain of negative to positive infinity. So just to explain what happens to it, plus 3 shifts it to the left by 3 units. Square makes this one larger, and the negative flips over, becomes positive. Minus 5 brings it down by 5 units as far as transformation is concerned, okay, for the graph. Nevertheless, it's a cube root function, and the domain is all real numbers. So f is a cube root function, is continuous on negative to positive infinity, therefore it's continuous over the given interval of negative 4 to 5. So let's differentiate. To differentiate, it's easier to differentiate this guy than this guy, okay? Let's do that. Two-thirds x plus 3 to the power of 2/3 minus 1 makes it negative 1/3 the derivative of the inside. So f prime of x is 2/3 x plus 3 to the power of negative 1/3. So one more time, 2/3 x plus 3 to the power of 2/3 minus 1. The derivative of the inside is 1. We don't have to write it. And so to rewrite this, we're going to put this underneath. 2 over 3 times x plus 3 to the power of 1/3. Now, we want to go with f prime equals 0. F prime doesn't exist. We notice this is a fractional format. A fraction of a over b is 0 when a is 0. It's undefined or does not exist when b is 0. So when the numerator is 0, the function is 0. When the denominator is 0, the function is undefined. So for this, we want to set f prime equal to 0, but it doesn't work. Why not? Anytime the numerator is a number, everybody. Large, small, fraction, doesn't matter, negative, positive, it can't be 0, so there is no solution. So f prime equals 0 doesn't produce any solution, no solution or phi. F prime does not exist, or meaning a fraction is undefined, you set the denominator equal to 0. Clearly, this is 0 if x is negative 3. Everybody can clearly see that. Now the question is negative 3 in between? The answer is yes. Therefore, negative 3 is an element of I. Want to remind you, let me just erase my work. This notation reads an element of, this is from the set theory, looks like an epsilon. That means, yes, it belongs to the given interval. That's the meaning of it, everybody. Meaning, yes, we can use that, because if it's not, you can. Therefore, we're going to go to the next step. That means f of a, f of b, and the critical point. So evaluate this function for negative 4, negative 3, and positive 5. So let's do that. So we are going to use either this one or that one, makes no difference. let's plug in -4 here. I hope you see that -4 and 3, they add up to -1. What is cube root of -1? -1. When you square it, you get +1. -5, -4. If I plug in -3, I hope you see that with 3 becomes 0, doesn't matter, cube root, square it. So this becomes 0, the answer is -5. Let's plug in 5. 5 and 3 is 8. Cube root is 2. Square it, you get 4. -5 is -1. They're all negative. So the largest value is this. Absolute maximum equals the largest value -1 at this pair. Absolute minimum is the smallest value -5 at this pair. So we do the writing in the same fashion. So it's pretty straightforward, everybody. We're going to continue with the same type of question. We're going to find the absolute max and mean for this function in this interval. F of x is x over x squared plus 2, and the given interval of 0 to 4. So the question is, what type of a function do we have? Where is this function? Continuous, or in other words, what is the domain? First and foremost, this is a rational function. What is a rational function? A function f is a rational function if f of x is in the form of n of x over d of x. N is the numerator, d is the denominator, and the denominator can't be 0. Where n of x and d of x are polynomials. The domain of f consists of all real numbers except the zeros of the denominator of f of x, namely d of x. In other words, you set the denominator equal to 0 and you exclude it. So x squared plus 2 equal to 0. And this happened not to have any solutions because when you have x squared and you add it to any number, worst case scenario, this is 0. This is always 2 or larger. So x squared plus 2 doesn't give you any solution. Normally it does. I want you to know that normally we have something else. It does it. You set it equal to 0 and you exclude that. So you say all real numbers except those numbers. In this case, the domain happened to be all real numbers. Doesn't happen for all rational functions. And so f is a rational function and it's continuous from negative to positive infinity. Therefore, it's continuous in the given interval of 0 to 4. So let's work on the next step. CP's f prime of x. So f over g, and we are going to use the quotient rule, f prime g. Let me erase that one more time. F prime g minus g prime f over g. As I mentioned it before, when I want to differentiate, I write the formula that I need and I follow it. instead of writing ddx of this, ddx of that, which makes it very tedious and way too long. So what is f prime? Just 1 times the bottom x squared plus 2. What is g prime? 2x minus 2x times x. And just write the bottom and square it. You combine these two into minus x squared. So f prime of x is minus x squared plus 2 over x squared plus 2. We are going to look at f prime equals 0 first. A fraction is 0 when the top is 0. Negative x squared plus 2 equal to 0, meaning two equals x squared, x is plus minus square root of 2. F prime does not exist when the denominator is 0. And we showed that x squared plus 2 can't be 0, so when you square it, it can't be 0 either. So f prime equals 0 does not give us any solutions. Why? So there are two answers, and square root of 2 is about 1.41. So is square root of 2 in between? Yes. What about negative square root of 2? No. Therefore, you can evaluate the function at these two endpoints as well as square root of 2. So what is f of x? X over x squared plus 2. Let's plug in 0. Obviously, when you plug in 0, you get 0 over 2, which is 0. Let's plug in a square root of 2. When we do that, we get square root of 2 over square root of 2 quantity squared plus 2. This is 2, everybody. 2 and 2 adds up to 4. So it's precisely square root of 2 over 4. Let's plug in 4. 4 over 4 squared plus 2. 4 squared is 16. You get 4 over 18, which is 2 over 9. Now, I hope you recognize this is larger than this. If you don't, you can go with a decimal representation. So this is absolute max, and this is absolute mean. So you are going to write absolute maximum is square root of 2 over 4, roughly 0.35 at this pair, square root of 2 comma square root of 2 over 4. Absolute minimum is 0 at 0 comma 0. We're going to repeat the question for the function. We want to find the absolute max and mean for the function f of x equals x to the power of 4 minus 18x squared in the interval of -4 to 1. As you know, this is a polynomial of degree 4 with the domain of all real numbers. So f is polynomial of degree 4 and is continuous from negative to positive infinity, and therefore is continuous in the given interval of -4 to 1. So we're going to start with the CPs. That means f prime of x, which is 4x cubed minus 36x. Because we want to set this equal to 0, we are going to factor it. And we notice 4 is in common, so is x. If I take out the 4 x, I get x squared minus 9. And this is a squared minus b squared. Which is x plus 3x minus 3. And if we set f prime equal to 0, we get 3 answers. This gives us 0. By the way, this 4 or any other number in front doesn't change the fact that x must be 0, okay? Positive, negative, small, large makes no difference. So x is 0, x is negative 3, x is positive 3. So there are 3 answers here. F prime does not exist, doesn't produce any solutions. Why not? F prime itself is a polynomial of degree 3 and it exists everywhere, the domain or continuity, if you will. Let's look at each number. Is 0 between a negative and positive? Of course. Is negative 3 in between? Of course. What about positive 3? No, it's larger than 1. So this is out. So you're going to write negative 3 as well as 0 belong to, that's an element of this set, so we can use those. We are going to go back to the original function, evaluated at these 2 endpoints and these 2 critical points. The purpose of this question was to make the following point. We, of course, evaluated at the endpoints, but in this case, we happen to have more than 1 critical point. More specifically, we have 2 of them. That's why it says f of c sub 1, f of c sub 2, f of c sub 3, however many. But you have to check to make sure the ones that you are plugging in, it's in between. So what is the function? F of x, x to the power 4 minus 18x squared. Let's plug in negative 4. Now, negative 4 to the power of 4. Let's start with this one. Negative 4 squared, everybody. This is 16. So negative 4 to the power of 4 is 16 squared, or 256. Minus 18 times 16 is 288. So 256 minus 288, which gives us negative 32. Plug in negative 3. Again, negative 3 squared is 9, which makes this one 9 squared, or 81. Negative 18 times 9 is 162. So 81 minus 162 makes it negative 81. If I plug in 0, class, clearly I get 0. It's not a big deal. If I plug in 1, 1 to the power of 4 or 1 to the power of 2 is 1, so we get 1 minus 18, negative 17. Absolute max is the largest one, and all of them are negative except this one, so the absolute max is 0 at this pair. Absolute minimum is the smallest one. Absolute minimum is negative 81 at this pair. We write absolute maximum is 0 at 0, 0. Absolute minimum is negative 81 at negative 3, comma, negative 81. Again, the way you write it is the way they want you to write, so you follow that for full credit. Find the absolute max and minimum value for this function. F of t is t times 4 minus t squared to the power 1/2 in the interval of -1 to 2. So the very first question we should answer, what type of a function do we have? And therefore, what is the domain? So we're going to change this to the square root. So f of t becomes t squared of 4 minus t squared. So what is f of t? F of t is the product of these two pieces. This is a linear function. This is a square root function. So f of t is a product of a linear function t and a square root function squared of 4 minus t squared. As you know, a linear function is a polynomial of degree 1 with the domain all real numbers, no restrictions whatsoever. But this has a restriction. What type of restriction? Let me remind you. When y is square root of x, x must be larger than or equal to 0. In other words, when the index, the index, when we don't write this 2, when the index is even, then the radicand must be positive. So the same thing here, 4 minus t squared must be greater than or equal to 0. Must be non-negative. That's a better statement. In any event, so how do we come up with the domain? We have to use what is called a sign graph. And so we are going to factor this into 2 minus t, 2 plus t. When we set it equal to 0, this gives you positive 2, this gives you negative 2. So there are two answers. Then the sign graph uses a number line from negative to positive infinity. And it says from negative to positive infinity t, it uses those are called critical points. That means zeros in this case. At -2, the expression 4 minus t squared is 0. At +2, also 0. You have to put them in order from smallest to largest because it may be more than 2. And then you figure out what happens as far as the value of 4 minus t squared is concerned in between, meaning less than -2, between the two numbers, larger than 2. And to do so, we use test points. Test points or short TPs. In between the two numbers, the easiest number would be 0, right? Between negative and positive. To the right of 2 would be 3. To the left would be, let's say, -3. Now, before we test it, please understand this is degree 2. This has two answers, and each one has exponent 1. Because the exponent is 1 or odd, they will alternate. So if you figure one of them, the rest of them alternate. 0 is the easiest number. If I get 0, 4 minus that is positive, so I get positive here. So if it's positive and it alternates, this become negative, this become negative. If you have any doubts, you can plug in. For example, if you plug in 3, you get 9. 4 minus 9 is -5. So that's how you get negative. So which means if we want this to be greater than or equal to 0, we want this one, which is between -2 and 2, and the domain becomes -2 and 2. F, which is a product of a linear function and a square root function, is continuous on the interval of -2 to 2. And therefore, it's continuous over the given interval of -1 to 2. So all we did was in essence prove that the function is continuous in the given interval. And so now we are going to go with the CPs and finding f prime of t. To do so, let me erase my work. I want to differentiate this, so I'm going to use the product rule on this one. So this is f, this is g, f prime g plus g prime f. So f prime, the derivative of t is 1 times either this one or that one, it doesn't matter, times 4 minus t squared to the power 1/2. But g prime, we're going to use this one instead of that. This is easier to do. 1/2 4 minus t squared to the power of 1/2 minus 1, which is negative 1/2. The derivative of 4 minus t squared is minus 2t, and then times f, which is t. And let me write this at top of this so you can see what's going on. So we have f prime g plus g prime f. Now we are done with calculus. We're going to simplify that. To simplify that, first and foremost, this is the square root, right? This one is also a square root, goes down and becomes a square root. 1/2 goes away. Let me erase the work first, so I'll show you. So 1/2 goes away, and negative 2 changes to minus t, right? So what we have, this is a square root. This is a square root. This one is a fraction. This is at the bottom with the square root format because it's negative 1/2 becomes positive 1/2. Then in the numerator, we have plus 1 minus t. The product of these three is negative t squared. Therefore, this one is this one. This one is this one minus t squared. Now, what is the common denominator? Obviously, this one. If I multiply these two, because I want to raise this, right? This comes out 4 minus t squared, which is 4 minus 2t squared over the square root of 4 minus t squared. I hope you realize the calculus part is not a big deal, and what I've done here is just purely algebraic. So let's rewrite that. So here's the function. Here's the interval. Here's the format. Here's f prime that we found. So f prime equals 0. A fraction is 0 when the top is 0. You move this, that means 2t squared is 4. Means t squared is 2. That means t is plus minus square root of 2. F prime doesn't exist if the bottom is 0. The bottom is 0 is 4 minus t. If 4 minus t squared is 0, that means 4 equals t squared. That means t is plus minus 2. There are 4 answers, everybody. And remember, square root of 2 is about 1.41. Is that in between? Yes. How about negative square root of 2? Negative 1.41? No. How about negative 2? No. How about positive 2? It's one of the endpoints. So we are going to evaluate the original function at these two endpoints as well as these two. These two happen to be really 1 because these two repeat. So we are going to use one of those formats. The second format is easier, and plug in those numbers. Starting with negative 1. So I hope you see that negative 1 squared is positive 1. 4 minus that is negative 1. 4 minus that is positive 3. My apologies. Square root of 3 times negative 1 is minus square root of 3. Let's plug in square root of 2. You get square root of 2 times the square root of 4 minus square root of 2 squared, and this is 2. 4 minus 2 is 2. So this one is square root of 2, so is this one, and it comes out as 2. Let's plug in 2. This is 4. 4 minus 4 is 0. Square root of 0 is 0, and everything becomes 0. Clearly, the largest value is 2, and the smallest value is minus square root of 3. So we write Absolute maximum is 2 at square root of 2 comma 2. Absolute minimum is negative square root of 3 at negative 1 comma negative square root of 3. Pretty straightforward. Find the absolute maximum and minimum values of the function f. F of x is x to the power of 2/3. The interval is -2 to 3. So the first thing is, what type of function do we have and what is the domain? This, we can write it as a cube root of x quantity squared or cube root of x squared. Both ways are fine. So what you're dealing with is a cube root function. As we discussed before, the domain is all real numbers. So we're going to write f is a cube root function, is continuous from negative to positive infinity, which therefore makes it continuous in the given interval of -2 to 3, closed interval of -2 to 3. Therefore, we're going to move on with the closed interval theorem, starting with f prime of x. To take the derivative, we're going to go back to this one, 2/3 x to the power of 2/3 minus 1, which is -1/3. This goes down, becomes x to the power of 1/3 or cube root of x. So this is the format we're going to write. F prime equals 0. A fraction is 0 when the numerator is 0. When the numerator is a number, it doesn't matter what type of number, small, large, negative, positive. It can't be, so there is no solution. F prime does not exist. A fraction is 0 when the denominator is 0. And the denominator is 0 when x is 0. Is 0 in between the given interval of -2 to 3? Yes, therefore 0 is an element of -2 to 3. We are going to go back to the original function, evaluated at these two endpoints as well as this critical point. So what happens? Let's plug in -2 into the function x to the power of 2/3 or cube root of x squared. So I hope you see that this is cube root of 4, cube root of 4, which is an exact answer, roughly 1.5874. As far as the number of decimals, as always write the exact answer. If they ask you for an approximation, then you do so. Otherwise, you don't. 0 is clear, simply gives you 0. There's really not much to it. Number 3 to the power of 2/3. That means square it, which is 9, cube root of 9, precisely putting it into a calculator, roughly 2.08008. So absolute maximum is the largest value. The absolute maximum is cube root of 9 at this pair. And absolute minimum is 0 at this pair. We write absolute maximum is cube root of 9 at 3 comma cube root of 9. Absolute minimum is 0 at 0 comma 0.